Okay, so now I'm going to teach you how to effectively read charts and tables. Okay, so all about interpreting results is all about reading the graphs and tables. So we're looking at this one here, and these pictures up here are actually kind of superfluous, but sort of fun to see. So you can see some of the birth defects that we're dealing with here. So these are atrophied testes, so testes that have gotten smaller, and then these are testicular oogenesis. So these are testicles that are normal in size but have eggs instead of sperm inside, so it's a sex reversal. But really what's important here is our graph. So the first rule about reading a graph is axes. Okay, you want to pay attention to the axes. What do they mean? So in this particular one, if we look at the x-axis, now generally the x-axis is going to be your independent variable. Oops. So in our case, it was the independent variable was the varying levels of atrazine. So you can see along the x-axis, we started with 0.1 parts per billion is what this ppb means, 25 parts per billion, and then the control. All right, so that's your x-axis. The y-axis is generally your dependent variable. So what changes as a result of the thing you manipulated? So in this case, you look male frogs with gonadal abnormalities. So this is the percentage that had birth defects, okay? And these are the different types of birth defects, the blue and the green. All right, and so now we can look at it and we can say, all right, as our atrazine goes up, interestingly, so this is a kind of a, I would never draw this graph this way. The 0 should be kind of over here, right? So you do 0 and then 0.1 and then 25, but they've got it as here. They've added atrazine, here they haven't. So let's just look in general with atrazine, without atrazine. You can see that the bars are higher with atrazine than without atrazine. So that seems to support our hypothesis that adding atrazine to the water causes more birth defects. But what's weird about this graph is as you go from 0.1 parts per billion to 25 parts per billion, the number of defects goes down, which is odd. So it's not dose dependent. My guess is with adding 25 parts per billion of the atrazine that so many other weird things are going on that you just don't even get to the developmental stage where you get birth defects, but it's sort of a mystery. But looking at it as a whole, with atrazine present versus the control, you definitely have more birth defects with the atrazine than without the atrazine.